So today, we're diving into one of the biggest cosmic detective stories of our time. It's all about a single, incredible star explosion that might just force us to rewrite everything we think we know about the universe.
Just imagine this. You're looking deep, deep into space. We're talking 10 billion light years away, and you see something that just shouldn't be possible. Well, that's exactly what happened back on February 19th, 2026.
Astronomers were looking at one single spot in the sky. They saw one star exploding, but the light from that one explosion was showing up in 5 different places at the same time. How is that even possible? Okay, let's dive into this, because the answer is honestly just as mind-bending as the puzzle itself.
So what they found was a supernova that got the official name SN 2025WN, but everyone lovingly nicknamed it SN Winny. And this wasn't some random find. It was discovered by a huge international team called the Holozomox Project after they'd been searching for 6 straight years. Now, this isn't just any old supernova. It's a super luminous one. We're talking hundreds of times brighter than your average star explosion. And it went off when the universe was just a baby, only about 3 billion years old. But the really crucial part, the whole reason we're talking about this today, is that its light is being split into 5 separate images. It's like a cosmic mirage. So how can one star be in 5 places at once? Well, the answer takes us back more than 100 years to a wild idea from Albert Einstein that shows how the universe itself can bend light like a giant magnifying glass. You see, Einstein realized that gravity isn't really a force, it's a curve in the fabric of space-time itself. Really massive things, like entire galaxies, create these huge warps in space-time. So when light from something far away travels past one of these galaxies, it has to follow that curve. And for us, way over here on Earth, that bent light can create multiple, even magnified images of that one distant object. And with SN Winny, the setup is just perfect. Between us and that exploding star, there aren't one but 2 massive galaxies sitting right in the foreground. Their combined gravity is so powerful that it's slicing up Winny's light and creating this unbelievably rare 5-image pattern. I mean, usually when this happens, you see 2 images, maybe 4 if you're lucky. 5 is almost unheard of. Okay, so a 5-image supernova is incredibly cool, no doubt about it. But why is it a potential game changer? Well, it's because this one discovery could finally solve one of the biggest, most heated arguments in all of modern physics, a problem we call the Hubble tension. So for years now, we've had 2 main ways of measuring how fast the universe is expanding. And here's the problem. They give us 2 different answers. When we look at the early universe, using light left over from the Big Bang, we get a number around 67. But when we measure the local universe right around us, using stars and nearby supernovae, we get a faster number, around 73. And that number just means that for every 3.26 million light years a galaxy is away from us, it's flying away that many kilometers per second faster. The point is, the numbers just don't line up. And this isn't some tiny rounding error. Scientists are so sure about their measurements that the margins of error don't even overlap. This is a real, fundamental conflict in what we're observing about the universe. You have to understand, the stakes here are absolutely enormous. This tension, this disagreement, might be pointing to a huge crack in our standard model of cosmology. That's the theory we use to explain pretty much everything. It could mean we're missing something huge, maybe some new kind of dark energy or physics we haven't even dreamed of yet. And this is where SN Winny makes its grand entrance. This lensed supernova gives us a third, totally independent way to measure the expansion of the universe. And it does it using a method that's basically like a cosmic stopwatch. The technique is called time delay cosmography. Think about it. Since each of those 5 images of Winny took a slightly different path around the lensing galaxies to get to us, those paths aren't the same length. So the light doesn't all arrive at once. There's a time delay between when we see each image appear, and that delay could be days or maybe even weeks. It's really such a beautiful and direct process. The star blows up, its light gets bent and split by the galaxies in front of it, and then it arrives at our telescopes in 5 separate packets. By measuring the exact time delay between the arrival of each of those images, scientists can then directly calculate how fast the universe is expanding. It's incredible. And as one of the scientists, Stefan Tobenberger, puts it, this method is so powerful because it's so direct. It's not like other methods that rely on a ladder of different measurements where small errors can pile up. Nope. This is a clean, one-shot calculation based on the geometry of space-time itself. And just to really hammer home how special this is,
The project lead, Sherry Suyu, said the chance of finding an event this bright, this perfectly aligned, it's less than 1 in a million. They hunted for 6 years to find this exact thing. It's a natural experiment of the rarest kind.
So as scientists are now measuring the time delays from SN Winny's 5 images, pretty much the entire world of cosmology is waiting on the edge of its seat. Because what happens next? Well, it could literally change everything. So really, it boils down to 3 possible outcomes. If Winny's measurement comes in high, around 73, that tells us something is probably wrong with our model of the early universe. If it comes in low, around 67, then it means our measurements of the local universe are probably flawed. And if it lands somewhere in the middle, well, that could mean everybody's a little bit wrong.
But that's the whole point. SN Winny is the ultimate tiebreaker. It's this clean, impartial referee that can step into one of the biggest debates in science and finally tell us who's right, or if the real answer is something nobody expected.
And that leaves us with this one, absolutely thrilling question. Will a single star that exploded 10 billion years ago completely rewrite our map of the cosmos? All of our theories are on the line, and the answer is being written, right now, in the faint, time-delayed light of SN Winny. We just have to wait and watch.